In this video, we're going to talk about limits of trigonometric functions, and specifically, we're going to talk about the tangent of x. And we're going to look first at where x approaches pi over 2 radians. But before we get into the specifics of this limit, I want to talk about the unit circle a little bit and about something that confused me when I first learned this topic. Namely, it is this x value right here. This x value is the input of this function. Specifically, it's the angle that we're talking about. And that is to be distinguished from this x value on the inner circle. This x in green and that x in yellow are two different entities. This x refers to this angle. So in this case, if we looked at the angle of 30 degrees, otherwise known as pi over 6 radians, we know that this x value is going to be the square root of 3 over 2, and this y value is going to be positive 1/2. Both of them are positive, actually. So the x coordinate is square root of 3 over 2, and the y coordinate would be 1/2. What would be easier for students at the beginning is to change that, instead of using x here, change that to theta. So if you did this, theta over pi over 2, tangent of theta, that would make more sense, because now we know that's the angle and that this coordinate here is the x coordinate. Let's now look at the limit as x approaches pi over 2 radians of the tangent of x. It turns out that the tangent of x has a period of pi. And this distance here, if you look at it from negative pi over 2 to 0, that's pi over 2. And then if you move to pi over 2, this total is pi. So let's look at the values of tangent of x with the help of the unit circle. Negative pi over 2 is the same as negative 90 degrees. So we're down here on the unit circle at this yellow point. Now, the x value of this point is going to be 0, and the y value is going to be negative 1. The tangent is the sine over cosine, otherwise known as the y over the x. So with 0 in the denominator, this is going to be undefined. That is why there is a vertical asymptote at negative pi over 2. Also of note is if you look at the slope of that line, which corresponds to negative pi over 2, that's a slope that is indeterminate because it is a vertical line. Now let's move 1/4 of a period forward. Whenever you graph trigonometric functions, that's the way to do it. So if we take 1/4 of pi, we're going to move 1/4 in the we're going to move, pi over 4 in this direction. Negative pi over 4, negative 2 pi over 4. Negative 2 pi over 4 is negative pi over 2. Okay, what is our tangent value at negative 45 degrees, which is negative pi over 4 radians? That's going to put us right here. And we could see that at this point on the unit circle, we're going to be at positive square root of 2 over 2 for the x value and negative square root of 2 over 2 for the y value. And when you put y over x, you're going to get negative 1. And of note is the slope of that line, which is y over x, which is rise over run, is going to be negative 1. So at x equals negative pi over 4, our input angle, our y value is going to be negative 1, like so. Now let's look at 0 degrees. At 0 degrees, we're going to be located here on the unit circle, and our x coordinate is going to be 1. Our y value is going to be 0. If we put y over x, we would get 0. And of note is that you have a horizontal line here corresponding to the input angle of 0 degrees, and that's a slope of 0. Finally, when we move to positive pi over 4, we again are going to have a slope of positive 1. Well, of 1, excuse me, but this is going to be positive 1 because that's going to be square root of 2 over 2 for both the x and y value. And again, the slope of that line is positive 1. So we are going to have a graph that looks like this. Okay. Now, the problem is we are asked to find the limit going towards pi over 2. We only have the limit as x approaches pi over 2 from the negative direction. So we need to graph another period here. So what we're going to do is we're going to move pi in this direction, otherwise known as 2 pi over 2 in this direction. And that's going to put us at 3 pi over 2 for our next vertical asymptote. Let's see, 2, 4, 2, 4. Over here. And if you add 2 pi over 2 to 1 pi over 2, this is going to be 3 pi over 2. Okay, but we're not really going to be interested in that part of the graph. All the action is going to be located here at pi over 2. So again, we're going to be at 0 here, at pi, just 1/4 of a period forward, we're going to be at -1. And then another 1/4 of the period, we're going to be at +1. So this is going to be the second cycle of this tangent graph. Okay, now we can graphically evaluate the limit as we approach pi over 2 from both the left and the right. Let's do from the left first. So here in blue, we are going to be looking at the limit as x approaches pi over 2 radians from the left of tangent of x. Okay, so here we are at pi over 2 radians. We're from the left, so I'm going to put my mouse right here and I'm going to keep going, and we could see clearly that we are approaching positive infinity. Now, if we approach pi over 2 from the right, we'll do that in green. The limit as x approaches pi over 2 from the right of tangent of x. We're going to put our pen on this green graph and approach pi over 2 from the right, and you could see this heads towards negative infinity. Therefore, they don't match, so this limit does not exist. Okay, folks, let's look at the limit of tangent of x as x approaches pi over 2 graphically, but in a different way. Suppose you can't remember how to graph tangent of x, you can't remember what the period is, etc. As you know, the tangent of x can be broken down to sine of x over cosine x, and then we can break this fraction down into 1 over cosine x times sine of x. So let's look at these two different components separately. If you look at the sine of x, here's the graph. The graph has a period of 2 pi. Excuse me. If we start at 0 and we separate this into 4 tick marks, which is how I think you should do it, we know this is going to be pi, otherwise known as 2 pi over 2. This is 1 pi over 2, and this would be 3 pi over 2. If you go to the unit circle, at 0 here, your y value is 0. So we would be here. At 90 degrees, your y value, which represents the sine of that angle, is going to be +1. When you go to pi, again, the y value drops down to 0, because again, this point right here is going to be -1 comma 0. That's the y value of that coordinate, and the y value at that coordinate corresponds to the sine of the input angle. So this input angle is pi, the sine of pi is going to be 0, and marching along, we're going to have this graph. This is the sine of x. Okay, if you look at the limit as the input goes towards pi over 2, whether you're moving from the left here or from the right, you can see that that limit is 1. So this is not a problem. That's going to be 1. Now let's look at the cosine of x and see where that takes us. 1 over the cosine of x, very important. Okay, the cosine of x is a similar graph, but it's a little bit different in that while it has a maximum of +1 and -1, and it has a period of 2 pi, if you look at the cosine of 0 degrees, that's going to correspond to the x coordinate. We're going to start at 1. At pi over 2, the cosine value is 0. At pi, the cosine value is -1. 3 pi over 2 comes back to 0, and you have a graph like so. Okay, now let's focus on this pi over 2, because after all, that's our limit. Now, as x approaches pi over 2 from the left, okay, so now we're looking at the limit as x approaches pi over 2 from the left of 1 over cosine of x. What's happening to the cosine of x? Okay, so we're going in this direction. As this value gets smaller and smaller, positive, right? It's always going to stay positive as you approach, but don't actually meet pi over 2. At pi over 2, the value is going to be 0. But as you get smaller and smaller and smaller positive, this whole fraction is going to get bigger and bigger and bigger in the positive direction. So the limit as x approaches pi over 2 from the left is going to be positive infinity. Okay, here's what I mean by that. If you have items in the denominator getting smaller and smaller and smaller and smaller to the point approaching 0, okay, here's 0. You're approaching it from this direction. Eventually, you're going to get down to 0.0001. What is 0.0001 in a fraction? That's 1/1000th or 1/10,000th, something like that. So if you put tiny, tiny fractions in this denominator, that turns into positive infinity. Okay, now we're going to approach from the right. Now here, our values, our y values are going to stay negative right up until the time they approach 0. Negative, but smaller and smaller negative. Look, here it's at -1/2. Here it's at -0.5. Here it's at -0.1. -0.0001. So let's put that in the fraction. Okay, -0.001. That's the same as 1 over -1 over 10,000. This is going to approach negative infinity. So if you have 1 over cosine x, you're approaching it from the left, it's positive infinity. From the right, it's negative infinity. Then that part of this product has an undefined limit, or I should say that limit does not exist, which means the whole tangent limit does not exist.